All right, so today we're going to do the pair of graphs that are secant and cosecant because they're really similar, kind of like cosecant. Sine and cosine had similarities to them where the period and the amplitude had the same rules and stuff. Secant and cosecant go well, they pair well together. But there are a couple things we need to review before I can teach you about those graphs. So if you've got blank paper at the end of your notability paper, that might be helpful. All right, we need to talk about the big five. I've been talking about that for a week. All right, so the big 5 points. All right, for sine, okay, talk me through the big 5 points for sine. What are they? How do they go? Where does it start for sine? Starts at 0. All right, and then for a normal sine, like everything about it is normal, normal amplitude, normal period, normal whatever. The next dot is 1. And then where does it go back to? Back to 0. And then what does it do? -1. And then what does it go back to? 0. Okay, those are the big 5. 0 and then up 1 and then 0 and then down 1 and then 0. Those are the big 5 for sine. The graph we're going to learn, which graph goes with sine that we've learned is the reciprocal? Very good. Okay, cosecant. So cosecant goes with sine. And so we need to, the relationship is reciprocal. So we need to do the reciprocal of the big 5. Okay, the reciprocal of the big 5. All right, what's the reciprocal of 0? No. What is the reciprocal of 0? No. Undefined. Thank you very much. The reciprocal of 0 is 1 over 0, which is undefined. What is the reciprocal of 1? 1. Okay, what is the reciprocal of 0 again? Undefined. What's the reciprocal of -1? -1. Okay, the reciprocal of 1 and -1 are themselves. And then the reciprocal of undefined. So we need to graph these. Does anybody know how to graph undefined? You actually do. Anybody know how to graph it? We did this in first semester. Mm-hmm.
It's like, undefined is like a parabola, right?
No? No. No. No.
Undefined is like a vertical line.
No.
Bro, no.
Okay, so actually Jaylani was the most right. She said a vertical line. So there are 3 undefined. So there are 3 asymptotes that we're going to draw. All right, let's go back to our graph. In order to graph cosecant, you have to graph sine first. So if you are asked to graph y equals 2 cosecant, you are going to first graph the big 5 dots for 2 sine. They're connected. You're not going to change anything. We've learned how to do that. So you're going to graph 1, 2, 3, 4, 5. Where'd it go? Here. 1, 2, 3. My eyes are playing tricks on me. Okay. So you're going to get the big 5 on there first. No changes. This is not new. You're going to label the period as the same, the amplitude is the same, like everything same, same, same. So we label our period. We'll label our amplitude 2, -2. Our period is what? 2 pi. So we label these. The only difference is you don't connect the dots. Okay, you don't connect the dots. You're with me so far? Big 5, labeling, everything's good. All right. Are you ready? So we're not going to connect the dots. Okay, so the 0 one. The reciprocal of 0 is undefined, so turn your 0 into undefined, which means turn it into an asymptote. If you want to use a highlighter feature, or if you want to use a dotted line, it doesn't matter, but it is going to turn into an asymptote. An asymptote is a boundary line that you'll never cross. That's why we can't connect the dots, because there's a boundary line there. Where's the next asymptote going to be? At 1, all right? So there will be another asymptote at 1, because that's 0, and 0 turned into reciprocal is an undefined. Okay, where's the next asymptote going to be? Okay. All right, if you were a betting person, where would the next asymptote be? 3 pi, and the next one would be at 4 pi, and so what's the pattern? Okay, the pattern is all the pi's. When the patterns happen on all the pi's, we call that k pi. K could be any number. It just follows the pattern of k pi. All right, the k pi, well, k. And so this is what we call our domain. The domain is now not going to be all real numbers. It has to skip all the asymptotes. So our domain is, change pens. Our domain is all real numbers except, and to write except, we do equals to with a line through it. All real numbers except the pattern of the asymptotes. And for this problem, the pattern of the asymptotes is what we call k pi, because it's happening regularly at a predictable pattern of every whole number of pi. All right, now what do we do with the dots that are left? Because we have 3 dots left. We have an upper dot and a lower dot. We can't connect them because we're not allowed to cross an asymptote. And so the rest of the graph of cosecant looks like this. It is we call it a branch. It's like a U shape that's stuck between the asymptotes. It can't cross. It won't ever get wider than the asymptotes. It just basically goes up to infinity. And the lower one does the opposite. Okay, and the lower one goes down to infinity. And then if we kept going, if we made kept the pattern following, the pattern would continue. There'd be an upper section and a lower section, and an upper branch and a lower branch, and over and over and over again. Okay, it does have, it's a repetition. All right, so now we need to talk about range. All right, range. I'm going to go to the whiteboard a minute to show you something about range. All right, so we say our range is negative infinity up to and stopping at -2, and then picking up again at +2 and going all the way to infinity. So that is called the graph of cosecant. So the graph of cosecant starts out with the 5 same dots as sine. You just don't connect the dots. Okay, let's try another one. So a fresh graph maybe. So if we have, for our graph, y equals negative cosecant 2x. So you think, okay, cosecant, which one did that match? Okay, that matched sine, so I need to do the big 5 dots for sine. So you start with the big 5, but it is a negative, so your dots need to follow the negative reflection pattern that they would have if they were. Okay, so there's my big 5. Label first. So what is the amplitude here? 1. So I'm going to label my amplitude as 1 and -1. What about the period? It's just 1 pi, which means the center number is 1/2 pi, which means the first number was 0 pi. So get those labeled. Because 2 pi divided by b, and b is 2, so 2 pi divided by 2 is 1.
I got that wrong on the test.
Oh, shoot. Okay. All right, now we're ready to make our asymptotes. And so our asymptotes are going to, again, be where the zeros are. So the first 0 becomes an asymptote, and the second 0 becomes an asymptote, and the third one becomes an asymptote. Now you have to, this pattern is slightly different. Okay, the first one was at 0. Where was the second one? It was at 1/2 pi. And then the next one was at 1. And so where will the next one be at? So if it's 0, then 1/2. Then 1, then 1 and 1/2. And then 2, and then 2 1/2. And then 3 and 3 1/2. So how often is it happening? Every half. So our domain is written because it's happening every half. The domain is all real numbers except k½ pi. Not just k pi, but it's happening every half as often. And then you're ready, once you've done that, the domain, to draw the branches. So you'll have an upper branch, and you'll have the lower branch. And make sure that they don't widen beyond your asymptotes. Okay, sometimes I'll look at some sloppy looking graphs and their branches are straying too wide and they're going beyond the boundary of each asymptote. Those asymptotes are like the prison bars. You can't go out of them. They stay within the asymptote. Yeah?
So it's k½ pi now because the period is half of one is the first one?
Exactly.
What if we get a number like 2/3 pi?
Then it will be k 2/3 pi. You look at where, just look at the first, the difference between the 0 asymptote and the next one. Okay, so that asymptote 0, the next one's half. That means the pattern is always going to be half. They're always going to be equally spaced. So if the next one was 1/3, then your domain is going to be k 1/3 pi. If the next one was 1/4, it would be k 1/4 pi. It's just going to follow the pattern. Okay? All right, anybody want to try range? What would the range be? Think about what the range was, and what would the range be? So let's go back maybe to our graph on the board. What was the range for the first 5 dots? It was -1 to 1 because that's what the amplitude was. So it was -1 to 1. So my range now is just 1 and -1. It just fills in the gaps of what we've got. So my range is now -∞ up to -1, and then +1 up to infinity. Okay. All right, let's do a secant. We've done 2 cosecants now. Let's do secant. Who do you think secant is going to get its big 5 from? Cosine, exactly. All right, so I'm going to erase what I just have here. And we'll try again. All right, so go ahead and write down y equals, there we go, and we're going to do y equals 3 secant, come on, there we go, 3x. And so now we're doing like, okay, secant. Secant is the big 5 of cosine. So do your big 5 of cosine. So that's going to start here. 1, 2, 3, 4. 1, 2, 3, 4. And every 4 hash marks. And we label it like we would for cosine. So what's the amplitude? Okay, the amplitude is 3 and -3. Okay, and then we label our period. And what is the period this time? I picked this one for you, Sam, because you were one asking about it. What's the period? 2/3. So this number is 2/3, which means this number is 1/3, which means this one is 1/6, and this one is 3/6 or 1/2. Okay, now we're ready to draw our asymptotes, and the asymptotes happen where it's 0. So where's the first asymptote going to be placed? No, not at 0. Where's the first time the dots are 0? 1/6. That's where the asymptotes go. The asymptotes go where the zeros were. Okay? Where the zeros are, right? Wherever the big 5 dots were 0, that's where an asymptote is going to be. Okay, where is the next asymptote? Well, maybe how about the asymptote over on the other side? What's this one? I'm drawing it on the left in yellow. What's that one? That is -1/6. Good. Okay, and then there's really technically one way out here at the end as well. Okay, there's one. So I have my asymptotes, which means I can do my domain. My domain will be all real numbers except what's the pattern for the asymptotes? K 1/6. And then we're going to do our branches. We've got a lower branch in between 2 asymptotes. We've got an upper branch. We've got a couple upper branches we can fit in. Okay? There's really infinitely many. They just keep going and going and going and going according to the pattern. But I had 2 upper dots and a lower dot right there. I could make more if I could fit it on my paper. And then we finish up with range. Think about what the range used to be, and then see if you can figure out what the range is now. Does anybody want to try the lower range? Negative infinity to what? Negative infinity to -3. That's the lower range. And the upper range picks up at what number? 3, and then goes up to positive infinity. Okay, can you move these left, right, up, down? For sure, but draw it first. Okay, draw it first, then start dragging the stuff left, right, up, down. It's the same rules. If it's in the parentheses, it's left, right. If it's outside of the parentheses, it's up, down. But work on your big 5 first. All right, and those are the graphs of secant and cosecant.